Alright, so today we're going to start looking at compound probability, where we're going to start being able to actually do things that are like more in the real world. My hand's going to look huge, so I apologize. Alright, we're not going to get to both addition rules today. We are going to get to one of them though. Alright, first thing, before you can even start doing the probabilities, you have to figure out what type of situation you're dealing with. Alright, two events are, my hand's going to look huge, I apologize, mutually exclusive if they cannot occur at the same time. What we're really going to be looking at is you doing one thing and seeing if two different types of outcomes could happen. Could you do two different types of outcomes at once? For instance, if I roll a die, I got a 2 and I got an even number. Does that make sense? I only did one thing. But 2 is both the number 2 and it's even. That would not be mutually exclusive. However, I cannot roll the die. Great, come on. Okay. And get an even number and get an odd number at the same time. Right? It's at the same time with one trial. That's the big key on that. Mutually exclusive kind of makes sense. Mutually means both things. Like I do something and you do it also. Right? That's mutual. And exclusive is where you kick out other people and you don't let others attend. So the evens exclude all the odds. At the same time, the odds exclude all the evens. They are mutually exclusive. Alright, I'm hoping that makes sense. If that doesn't make sense, you're allowed to cheat on me. Go find another math teacher, ask them what they think. There's lots of them on YouTube. They make much better videos than me. Right? See what the definition is going to be the same. The meaning's going to be the same. Whatever words you can find out there that click in your head, use them. I'm going to tell you the stuff that like I have found that helps people. Or I'm not going to do good at teaching it. Right? So, I really like the dice thing. Remember, evens are not odds, odds are not evens. Determine which events are mutually exclusive and are not when a single die is rolled. Right, so right away, if I get an odd number and getting an even number, I cannot do both of them with one trial. That means that they are mutually exclusive. And I'm going to usually just put ME for mutually exclusive, if just so you get ready. That's what I'm going to be doing a lot. Now, notice they don't have to be exactly the same thing. Getting a 3 and getting an odd number, I can get an odd number that's not a 3. Not a big deal. The thing is, can I get both a 3 and an odd number at the same time? With one die, one trial? Yes, I can. If I can, then they are not mutually exclusive. And that right there is going to be the number one reason why mutually exclusive is going to be difficult. Not because the concept's going to be hard. Although, until you get that and like see what they're talking about, you can get tricked. However, what's difficult is the question you have to ask yourself, can I do it, is a positive question, and that leads to a negative answer. If I get a positive answer there, my actual answer seems negative. That is why mutually exclusive is difficult. If we had a word that meant not mutually exclusive, it's because mutually exclusive has a negative definition. They cannot occur. That's the biggest problem. All right. Nots mean you can do it, and if you can do it, then you have a knot. All right. Getting an odd number and getting a number less than 4. Well, number's less than 4. Well, right now we're rolling a die. That's a 1, 2, or 3. Could I get an odd number if I did that? Yes. One does not have to automatically equal the other. It's just could. Is there a way that I can do both of them at the same time? Odds are 1, 3, and 5, right? On a die. The 1 and the 3 are the same on both. So that is not mutually exclusive. Huh. Well, no. I was gonna say, not me. It's unique. They have some on both. Never mind. That would only work if I was there in class. Getting a number greater than 4, that's a 5 or a 6. Getting a number less than a 4, that's a 1, 2, or 3. None of those match. So that is mutually exclusive. Alright, now we're going to draw a single card from a deck. Alright, getting a 7, getting a jack. None of the jacks are 7s. None of the 7s are jacks. They are mutually exclusive. Clubs and kings. There is a king of clubs, right? That one card is both a king and a club, so he is not mutually exclusive. Pollen is killing me. I apologize. Getting a face card and getting an ace. That's not a W. That's an N. Aces have no faces. Alright? None of the face cards are aces, and none of the aces have faces. That's mutually exclusive. Getting a face card and getting a spade. There's a king of spades, a queen of spades, jack of spades. Not mutually exclusive. Alright, we're on page 2 of those notes. Now that's a big deal. Are they mutually exclusive or not? Big deal. Oh, this looks kind of fuzzy. Sorry, the zoom thing is right there on the lens. That doesn't even look a whole lot better. If two events are mutually exclusive, the probability that A or B will occur is, you ready? So the probability of A happening, get used to formal writing because you're going to have to read some of that stuff. I hate it for you, but you're going to have to be able to read math, not just do the word problems. The probability of A I wrote this formula backwards. Hold on. The probability of A or B happening, right? If there's no overlap between them, if A is completely separate from B, then that is the probability of A plus the probability of B. Sorry, I started writing it backwards because I've always written A probability of A plus probability of B equals that. But I apologize. At least it's a video, and half of y'all weren't writing anything down until after you see the whole thing anyways. Alright. So, if I'm looking for A or B, I can look at them separately and add up their probabilities together. Let's do 3. Alright. The box contains 3 glazed donuts. 4 jelly donuts. I actually like those a lot. 5 chocolate donuts. Surprisingly, not my cup of tea. I'll eat them, but if a person selects one donut at random, find the probability that it's either a glazed donut or a chocolate donut. Now, I'm going to do this by the formula thing, just to show you it, but yes, there's easier ways to do that than this. Alright, there's 3 and 4 is 7, and 5 is 12. How about that? A dozen donuts, right? Glazed, so the probability glazed is 3 out of 12. Don't reduce because we're going to have to add, right? Chocolate, probability of chocolate is 5 out of 12, right? 3 over 12 plus 5 over 12 is 8 out of 12. Probability of glazed or chocolate would be 3 plus 5 is 8 over 12, which reduces, 4 goes into both of them, 2/3. Now, yes, you can find the probabilities separately and add them. Or you can find out the total things that fit in that category and add those together and then do the total. So yes, you could have just as easily taken 3 and 5, added them together and gotten 8 out of the total 12 because there's no overlap. Political rally. There are 20 Republicans, 13 Democrats, 6 independents. If a person is selected at random, find the probability that he or she is either a Democrat or an independent. So, 13 out of, this is what, 33, 39? 13 out of 39, hey, that reduces. 6 out of 39. Together, that is 19 out of 39. And 19's on my prime list over there on the wall. To your left, up. Probability of D or I is 19 over 39. A weekend day, there's Saturday. Saturday's 1 out of 7. Sunday's 1 out of 7. So we have 2 out of 7. That says weekend, by the way. Alright, we're going to, this is tomorrow. Just so you know, tomorrow. Only things I have left are to get you used to like some set theory stuff and do some problems. So we're going to show you like how you can figure out whether things are mutually exclusive or not. I'm going to lower that so that my hand's not quite so huge. That's not so bad. Alright. We're going to determine whether it's mutually exclusive or not. And I'm going to try to get you a little bit used to like the group theory stuff. So if the question is it mutually exclusive or not? Right? So if it's mutually exclusive, then these two, probability of A, probability of B, will add up to this one. What's 1/4 plus 1/2? By now, you've already switched 1/2 to 2/4 and added 1/4 to it and gotten 3/4. If you haven't, you know, get over your wave week and get back to work. 3/4 is not 5/8. It's 6/8 because I can unreduce. Alright, so a quick rule of thumb, just so you know, if it's not mutually exclusive, this hold on, let me just write it down so I can then point to it. If it's not mutually exclusive, then probability of A or B is going to be less than the probability of A plus the probability of B. Or probability of A plus B is going to be bigger than the probability of A or B. We'll do another one. Probability of A is 3/10. Probability of B is 3/10. I knew that was going to bother me. The probability of A or B is 3/5. 3/10 from the probability of A plus 3/10 from the probability of B. 6/10. 6/10, both even. Reduce them by 2. Look at that. 3/5. It is mutually exclusive. Next one, I'm telling you that they are mutually exclusive. Alright? The probability of A is 3/5. The probability of A or B is 9/10. We need to find the probability of B. And I'm telling you that they are mutually exclusive. Well, this is our formula. A or B is 9/10. B, probability of B is a question mark. Probability of A is 3/5. I know I'm going to have fractions. I know I'm going to be adding and subtracting. Might as well get common denominators while I can. 3/5, we just saw from the last one, that's 6/10. So, 6/10 plus what would get me to 9/10? Y'all okay with that? Kind of makes sense? If not, turn off your AirPods. It's really hard to hear me over your music. Right now, John is telling me that it's not that loud. Jasmine's saying she's not listening to music. Alright. There we go. There are 5 nickels. Boop. There we are. There's 5 nickels, 5 dimes. I think it's ironic that I just made my dimes bigger than my nickels. If you don't get that, I am too old. And 3/4 in your pocket. You randomly pick a coin. Is it a nickel or a dime? That's the question. So, none of the nickels are dimes, none of the dimes are quarters, none of the quarters are dimes or nickels, none of the nickels are quarters, right? Every little row here is mutually exclusive to the other rows. Alright, so nickels have 5 out of 13. Dimes are 5 out of 13. Or, there's 13 coins, 5 nickels, and 5 dimes. Either way, you have 10/13. And I've used up like almost 20 minutes of your time. So, we have like 10 minutes worth of work left. We'll be good. See you tomorrow. Tomorrow we're going to do not mutually exclusive. It's not going to take as long, but it's going to get a little bit trickier. Wednesday, I'm going to teach you how to use tables, and that's going to be way better because that's going to take these two things and give you a better picture of what's going on. And it should be easier, although we'll be able to do more difficult problems. Bye. See you tomorrow.